Hello everyone. Good morning, good afternoon, or good evening from wherever you're joining. Thanks for joining this session, and this especially for the questions you might have. Myself, Kalyan Janaki. I'm a senior big data specialist at AWS. So day in, day out, I work with different customers ranging from startups to large enterprises and ensure they are successful in AWS cloud to build their analytics applications, productionize them, and successfully operate them. Along with me, we have other colleagues, Aarti, Ram, and Raghav on the call to help answer your questions and clear all your questions that you might have. So I would let Aarti introduce herself. Aarti, can you introduce yourself?
Hi, everybody. I'm Aarti Srinivasan, and I'm a senior data lake architect with the AWS Lake Formation Service team. I've been with AWS for 7 years now, and I really love interacting with customers and helping them to build their data lakes. Nice to greet you all.
Thank you, Aarti. Ram, do you want to go next?
Hey, hello everyone. This is Ram, Ram Kumar Notat. I go by Ram. I'm a solutions architect focusing on analytics services, and happy to be here, excited, and we are surely here to go through the questions and help you with anything that we can.
Sure. Raghav, you're the next.
Hi everyone, my name is Raghav. I'm Principal Solution Architect. I'm an account SA. That means I work directly with customers. I'm based out of Boston. I've been with AWS about 3 years, and I'm specialized in data analytics and AML. Happy to be here and happy to answer any of your questions. Again, it is open. You can ask any questions within analytics. We are happy to provide answers to you.
Yeah. Everyone on the LinkedIn and YouTube, feel free to say hi and tell us from where you are joining. Okay. So I see people joining here. Hello. Hi to everyone who's saying hi there. Thank you. Thanks for joining our session. So it could be any of the AWS Service Analytics portfolio. So if you are working on big data analytics, if you have questions surrounding EMR, or if you have any questions on one of our latest features, right? So we have serverless data warehousing like Redshift serverless, and we have EMR serverless for your serverless big data processing. And if you have any questions around data governance, like how to use row level, column level access controls using lake formation, we are here to help you. And I'm looking at some of the questions here coming up here. Let's take a look on, we have a question on search here. So do we have any session on choosing the right instance type for master and data nodes for Amazon OpenSearch? Raghav, do you want to take out this question?
Yeah, I can take that question. The first thing is like a master node. That is where it basically orchestrates. It's kind of an engine. It takes care of everything there. So when you are doing the master node, right, when you are choosing the instance type, it all depends on how many number of nodes you are going to use it. For example, let's say if we have like 10 nodes, and then next thing you have to think about is how many shards you are going to use. Depending upon that, right, you need to choose. For example, if we have any number of shards like close to 2000 plus, you can start with M6G large. But if you have like a more data nodes like 30 or more, or maybe 5000 shards, then you can go with C6G. So depending upon your data nodes and the shard, that is where you have to choose. By default, start with M6. And then when you keep on working on increasing your data nodes and shard, depending upon your data size, you can move to larger instance like C6 and maybe even R6. Now coming down to data nodes, right? Data nodes is meant for, that is where you are going to store all of your data. Data is going to store in indexes, and then you are going to perform like either website search, or you are going to build log analytics. And by using OpenSearch service dashboard, you can run the queries against OpenSearch cluster. So data nodes, again, you start with M6G, that is where the general purpose. And if you are looking for website such kind of a workload, that's where you can look for R6GD. And if you need like a faster kind of a thing, once you test with your general purpose with the M6, then you can move on to the R6G. That is where we would recommend for your production workloads. That way it can balance both performance in terms of memory and CPU as well. And R6 is recommended for log analytics or operational analytics, and whereas R6GD is recommended for website search workloads.
Got it. So, Raghav, when you say R6G, these are all Graviton instance,
Yes,
right?
yes, Graviton, yes.
So OpenSearch currently supports Graviton instance, and customer can get that cost optimization by using them. Do you want to talk a little more on that?
Yeah, so instead of using like a regular normal instance, we always recommend customer to use Graviton 3, because you get best price per performance. At least you will save like close to 40 to 50% depending upon instance size you use it, and also you'll get a best performance. That's the reason we are suggesting to use Graviton instance. Again, in addition to the Graviton instance, I mean, generally, right, website, be it a website search or a log analytics or operation analytics, you are going to use OpenSearch service for a very long period of time, right? It could be a year or two. If that is the case, you work with your account team and further work on reducing your cost, right, by using reserved instance, or you can even sign up for compute savings plans as well. So that way you can get the price for performance as well as you can reduce the cost, because other than like when you are started working on initially building your operational analytics or a log analytics pipeline, or trying out Amazon OpenSearch service for your website search, you can start with maybe on-demand instances, and maybe start with basically M6, that is general purpose. Once you tested everything, it's all good to go. We highly recommend using Graviton 3 instance with either reserved instances or maybe compute savings plan. That way you can further reduce the cost.
Thank you. Thanks, Raghav. Yeah, that's interesting, right? It's always interesting whenever I see a question on OpenSearch, because I see OpenSearch for different use cases, right? I've seen customer using it for analytics, for searching, and also I've seen a huge adoption of OpenSearch in application performance monitoring for application observability, right? So it's an interesting service, falls both in the analytics and also observability. So thanks, Raghav. That was definitely a detailed explanation. I'm trying to take a look at other questions that are coming in. Okay, we have a question here where a customer is asking, you just mentioned about Redshift serverless. So how do I choose when to use Redshift serverless than the standard Redshift for my databasing use cases? So who wants to take this question? Ram, do you want to answer this?
Sure, I can pick that up. So before going into when to use, right, Redshift serverless, the difference between Redshift serverless versus the provision clusters is, with Redshift serverless, the activities of figuring out what type of node to use and how many node to use, that has been abstracted away, right? But it still has all the goodness of the provision clusters. So you have both the ease of just spinning up an endpoint and starting your data warehouse, plus the performance that you get from your provision clusters as well. Now, the way I would look at when to use Redshift serverless versus provision clusters is, if you are starting a workload, my recommendation would be to first start with serverless. The good news is you can always switch between the two. It's not once you start with one option, you have to use that. You always have an option to move from serverless to provisioned, and the other way around, using the latest snapshot that you have. So it's a very simple process to do that. So if you have a completely new workload and you are not really sure how the workload is going to be, that's a good pattern that you may want to look Redshift serverless for, because the you are not sure what is the size that you want to provision and what is the node that you want to use, right? So that's one area. The other thing that I have seen customers getting a lot of benefits with serverless is their lower environments. Because if you look at the lower environments, the typically you will see that there is too much of variability in the load that you get, because there are so many things. It could be holidays, it could be weekends, it could be some production releases, because nearing to the production release you may have a lot more activity in a lower environment, but once it is moved to production then it may come down, right? So it all depends on the various activities and the various development cycles that you have. So that's where customers have got a lot of benefit in moving to serverless. So those are the areas that you may want to look at. Anything that you are starting with, lower environments is something that you may want to start with, so that you can take a look at serverless. But even in other scenarios, like for example your production clusters, if you think you want to evaluate, there are tools that are available. So we can help you with some tools that are available, which can identify whether moving to Redshift serverless can save cost or not, right? So that's always there, and I would surely recommend running that and figuring out what is the best option to run between the two.
Okay. Thank you, Ram. So we have another question in YouTube here. So basically, data lakes can be used for training ML models. However, for real-time ML inference scanning, data lakes, basically Delta Lake tables in S3 is too slow compared to database. What kind of strategy should we follow here? So if I understand, question here is like, what's the strategy for real-time machine learning inference? So who wants to take this question? Ram, do you want to answer this question?
Sure, I can start, and maybe others, if you want to add, please pitch in as well.
Definitely.
So when it comes to batch inferences, that's where the object storage like S3 can really help, right? Where you have the bulk amount of data sitting there, and you can have your inference done on that. So that's one use case. But to the question, if there are real-time use cases, what you can also do is there are multiple options that you have depending on where is your data gravity. There are one option is the usage of real-time feature store in SageMaker.
Perfect.
So that's one way of getting that high performance on some of those real-time use cases. That's one way of looking at it. Now, there could be other cases where we just talked about Redshift some time back, right? So the Redshift also comes with an inbuilt machine learning capability where you can have your models created, let's say, for example, in SageMaker, and bring that model into Redshift. Now, when you have data that is coming in and you want to do something that is on the fly, you can have that function used in Redshift, which is nothing but it's nothing but a SQL, which is making use of that function that is created and user-defined function, and it generates a prediction for you. So there are various options, but if you are really looking at from a performance standpoint, the first option would be to explore the real-time feature store.
Got it. So that's definitely good explanation here. As I said, whenever you say real-time inference, basically you'll have to use SageMaker endpoints, right? So you can deploy your model as an endpoint, and then as your real-time data is coming through a streaming services like managed streaming for Kafka or Kinesis, basically you try to do a real-time processing and make a request to a SageMaker real-time inference endpoint, which can make a real-time inferencing instead of trying to scan your data from Delta Lake, right? So basically have a model endpoint from SageMaker for the sake of real-time inference. We have a decent amount of blogs that cover these areas. So definitely, I hope we answered that question. I'm taking a look at the different questions here. Meanwhile, I have a question here. So what is the best way someone to get started with lake formation? So Aarti, do you want to answer this question?
Yeah, sure. So what is the best way to get started with the lake formation? So for this is a good question, and we definitely have a customer-facing workshop page. It provides a hands-on lab on a two-user scenario. it illustrates permissions with the sample data sets, and this will be a good place to get started as it simplifies the process with the CloudFormation template. It creates two data lake users, it creates a data lake admin, and it sets up all the required IAM role permissions for these users. And you can explore the different features of lake formation, including cross account sharing. And it also has illustration now for using EMR runtime roles to access lake formation managed tables. And this has been a frequently asked from very many big data users, and so it's definitely a good place to start hands-on checking out the features of lake formation. And lake formation workshop is a page that I would recommend. So you can Google up and search for AWS lake formation workshop, and it should lead you to the page. And lake formation's documentation is also hosting a lot of tutorials in a get started fashion, so that illustrates different use cases, cloud formation templates to help you ease into exploring the features of lake formation.
Thank you, Arti. While answering this question, I saw you brought in an interesting point about EMR, IAM roles, right? I would like to talk a little bit about the new feature that's been released recently where EMR can now support the job scoped roles. So basically, you have an IAM role scoped to an individual job, and that can make use of lake formation policies, right? So basically, you can have a different permissions for a different jobs running on a same cluster making of lake formation, right? So basically, this is currently supported through EMR Steps API. So if you are using EMR Steps API to submit the jobs on the cluster, you should take the benefit of this data governance of lake formation feature.
Hey, Arti, one question. So with that feature,
Yes.
so we will be able to have like each, let's say there are different jobs based on different teams, you can have visibility rules applied based on those various teams on the same data set itself, is it?
See, how the concept works is you are scoping information permissions on an IAM role. Okay, you can have as many IAM roles, and you're going to give access or use lake formation to define access to each individual IAM roles, permissions to certain database and tables, and the actual data is sitting on S3. These database and tables are sitting on Glue catalog, data catalog. Okay, so now when you're running EMR steps, all you're doing is associate role for that particular steps API. And within that steps, you can have multiple Hive jobs or Spark jobs like that. So you are scoping the permissions to that IAM role. So EMR, while running, that's why it's called a runtime, while running, it's going to scope down, take the permissions, ask for permissions from lake formation based on that particular IAM role, whatever is granted permissions using lake formation's permissions page. So that's how you scope down the permissions for individual IAM roles, and EMR ties the permissions IAM roles to steps.
Got it. Yeah, thank you.
That was definitely a good learning today, right? So making use of lake formation and job scope roles is definitely a great data governance feature. And the next question that we have here is, when do we choose between Kinesis Data Analytics and Flink on Amazon EMR? So basically, we can run the Flink streaming jobs on EMR. And also, we do have a managed service, Kinesis Data Analytics, to run Apache Flink applications. So how to choose between them? So this is a question that we have. Raghav, do you want to answer this question?
Yeah, I can take that question. So I would say it depends on your use case, right? Why I will say use case. Kinesis Data Analytics is basically managed service, and it is all from Apache Flink open source, right? We only made it like a managed service by using by providing you like a software hardware so that we make it easy, right? Whereas Apache running Apache Flink on EMR, again, that is also managed service, but the EMR comes with many other big data frameworks as compared to Kinesis Data Analytics. If you are dealing with like any complex stream data processing, for example, let's say if you are running a market campaign, right? maybe you wanted to see how that campaign is performing and where you wanted to track the metrics in real time, maybe every 1 hour, how we are doing or not, right? The simple example could be like a Prime Day where Amazon is doing Prime Day and we are selling maybe particular Alexa devices. You wanted to build a matrix, real-time matrix, right? Using Kinesis data analytics is the right thing to do as compared to running a Apache Flink on EMR. All right. And again, I will tell you one more difference. I said depending upon your use case. Let's say if you wanted to make little bit of some kind of a custom configuration in Apache Flink, that's not possible with Amazon Kinesis data analytics because it is serverless. Whereas EMR is basically it's a managed service. Behind the scene, you have a EC2 instance and you have a access to the software where you can do those custom configurations based on your needs.
So thank you. So now that we discussed about Kinesis data analytics, I wanted to talk a little bit here on the new feature, Kinesis Data Analytics Studio, right? So whoever asked this question, you should definitely take a look at Kinesis Data Analytics Studio if you have not already tried, because Kinesis Data Analytics Studio, a new service that we're trying to offer, where a managed notebook experience, right? So basically, you can have a notebook, Zeppelin notebook environment, and develop your streaming applications interactively. So we have very good documentation and few examples available in the blogs. So we are currently supporting the Flink latest table API. So it's like democratizing the streaming analytics, wherein which trying to bring the streaming applications into every single user. So it's like you create a table and start writing a SQL queries that get executed on the real-time streaming data. So I've seen a lot of adoption, and it's like super easy to develop streaming applications. Thanks, Rado. Thanks for that answer. Moving on to our next question here. What are few use cases of Redshift data sharing? So is there any specific use cases customers are using it for? Like, what are some scenarios? Ram, do you want to answer this question?
Yeah, sure. Actually, that's a really cool feature. If you look at Redshift data sharing, right? So that has changed the way customers think how they want to use their data. Because see, earlier before the RA3 instances came out, there was a coupling between the compute and the storage. Now with the Redshift RA3 instances, those two are completely decoupled. So that's how that data sharing concept came into picture, where you have the storage separately and compute separate. Now what that enables is predominantly what we have seen is one, there are multiple lines of business within the organization who wants to have autonomy on the data that they own. As a producer, they want to have control on the data that they own. But at the same time, as an organization, as an enterprise, they all need to have access to all the data. Only then they can bring in more analytics use cases, derive insights and things like that, right? So that's one use case where we have seen a lot of customers going with data sharing, where you have sharing across these various lines of business, but each one of them still has the complete control on who is accessing what. That's one use case that we have seen. The other use cases where we have, for example, multi-tenant environments. There are customers who has various teams who are using the data or data warehouse, right? And there could be some teams who are like, let's say, data science user who might be running heavy queries, and there might be another team who is just making use of dashboards which is very predictable, right? So because the queries are already out there, they are hitting the dashboard, so it's very predictable. And there could be another cluster which is making use of or doing some ETL activities. Now what you can really do is you can have your ETL process write the data and have that data as a data share, and the same data share is being accessed by your dashboarding cluster and the machine learning cluster. Now the advantage here is both of them are looking at the same data, but at the same time these two consumers are having completely different compute that they want to use. So they are not interfering in the other's business, but still has the same data that they are looking at. So that's another place where we have seen a lot of customers going into the data share.
Yeah.
The
Thanks, Ram. Because
Sure.
that's so interesting, right? How one feature leads to another feature, right? Initially, we wanted to help customers to bring in the feature of separating compute and storage. And separating this compute and storage through RA3 instances is getting other advantages like this data sharing, as you said, right? So like you're trying to share your cluster data with other cluster so that the ETL job happening and immediately the ML people can work on ML immediately, basically, right?
Exactly.
So,
And you know what? Earlier we were talking about Redshift serverless, right?
mhm,
The data share can work with serverless as well. So
mhm,
now you might have a producer cluster which is creating the data share, and you have a serverless endpoint where that serverless endpoint will come up only active when somebody is querying and using this data share, right?
right.
So all of that can play together.
Just wanted to put myself into a customer's shoes here and see. So it's not supposed to be confused between Redshift data sharing with the Redshift Spectrum, right? So Redshift Spectrum is actually to query the data in S3, but here data sharing is which is part of the cluster. Do you answer it that way?
Yeah. Actually, thanks for bringing that up. So those are two different concepts. Yes,
Mhm,
we should not get confused with those two. To your point, yes, Redshift Spectrum is where we are extending our data warehouse into the data lake.
mhm,
So you have the data that is sitting on S3, and you have very optimized compute processes or nodes which are directly working on S3 in place on S3. The reason why I'm emphasizing on that is there are many solutions where you might be able to go against the many of the object storages and things like that, right? But the advantage of Spectrum is that is in place query. So what that means is you are not moving the data around. You are actually bringing the compute and querying the data where it is, and then getting the results back. So that's what is Redshift Spectrum does. Whereas to your
right.
point, the data sharing is you are making use of the Redshift managed storage. That's the terminology that's been used for the storage that is used for Redshift.
Mhm.
So making use of those tables available for other Redshift clusters. So that's what is Redshift data sharing.
Got it. Thank you. That's
So
definitely a good
one thing I would like to add here to that use case is, Kalyan. So for the Redshift data sharing, essentially you don't want to share the full data, right?
Mhm.
You have tables with PII information. You don't want to copy it into entire table into another's Redshift cluster, or for any organization subdivisions in the company. So you are essentially creating a data share. You can create, when you create a data share, you can put together a compendium of different databases, tables, and create a data share, and then share it with any other teams within your organization, or it could be even outside cross regions.
Yeah.
So you are essentially using it as a tool, also mechanism, also to mask data which you don't want to share, certain columns that you don't want to share. So essentially you're using that for data shares for that purpose also.
Thanks, Arti. Definitely, that's a good explanation there. So the next question I wanted to put in here is about with lake formation being our central model for data governance. So do you want to explain how different services are currently integrated with lake formation? So we have a portfolio of AWS services. Like, can you go ahead and explain what all services currently integrate with lake formation and who can take advantage of the data governance model?
So that's a good question, and a good segue to, like, when we are discussing about the Redshift spectrum, right? So
Yeah.
let's start with the Redshift spectrum. So you have, for a Redshift spectrum to work, you already have a running Redshift cluster, and you want to use its analytics query engines capabilities and good data in S3's data lake. Now, how about if I can use lake formation to grant or revoke permissions for those data sets sitting on S3, and these are already cataloged in my Glue data catalog. We can
Mhm.
definitely use lake formation for that purpose. So now there are two ways which you can use the Redshift spectrum. One is, you will typically use an IAM role, attach it to the cluster, and now you create a Redshift spectrum schema, an external schema in your Redshift cluster SQL client, and you point that to any database. That spectrum schema can point to any database Glue's data catalog. And you can use the IAM role, which is attached to the header, as a Spectrum's role. And you can then grant permissions for your S3 datasets on that IAM role using lake formation. So that's a one use case. The second one is with the recent launch of the federated identity mechanism access for Redshift clusters. The IAM user who is logging in, he doesn't have to separately have another IAM role or assume another IAM role. Now the IAM user itself, that user's permissions can be used through Spectrum to access the lake formation managed tables. So there are two ways. So this is the new addition using Redshift Spectrum. So we have covered Redshift Spectrum. And in my demo, I have also covered how to use Athena in my previous webinar series. So you can use Athena to directly query datasets in S3 and use the Glue catalog. Now, lake formation permissions can be used to manage permissions on who can access the IAM users and roles that the Athena uses. Lake formation can be used to manage permissions for those tables. Apart from Athena and Redshift Spectrum, we can also use EMR. We just discussed a few minutes ago. EMR's step functions step APIs can be used with the runtime roles. So lake formation permissions can be defined on those IAM roles, and you can run Hive and Spark jobs. Apart from these, you can also use Glue ETL. Glue ETL also integrates very well because essentially lake formation is built on top of the Glue's data catalog. It applies permissions on the Glue's data catalog metadata. So you can use Glue ETL to access these lake formation managed tables.
So in short, if I have to say, you can use lake formation permission modeling in Redshift Spectrum, Glue, Athena, and EMR, right? So
yes.
These are the 4 services surrounded by a centralized governance model of lake formation.
Yeah, right? For now, yes.
Thank you. With that said, let's see our next question here. So we're trying to shift the gears here to streaming analytics. The question, one of the most popular question I see here. When do I choose between Kinesis data streams and MSK? Trust me, this is like so common question I see here, right? So Kinesis data streams, one of the first streaming service that launched in streaming portfolio from AWS. And then we got in MSK, which is managed service streaming for Apache Kafka. And we all know Apache Kafka being super popularly adopted open source streaming solution. So I'm not surprised with this question. So how to choose between Kinesis data stream and MSK? And also, how does MSK serverless play the role here? So Raghav, do you want to answer this question?
Yeah. Again, they both meant for same thing, right? Same thing means like they both are stream storage services, right? When you are collecting like a real-time data, right? Whether it is coming from your applications or it is coming from IoT sensors, you need to basically store the data in a storage so that multiple consumers can consume the data at the same time, right? That is where we need streaming service, right? So Apache Kafka, basically it's a very popular open source. That's the reason we made it like a Amazon
managed
MSK.
Service.
Yeah, managed service. That's called Amazon MSK. And then Kinesis data streams, again, that is serverless as compared to this. And we do have MSK serverless. We come to that later part. So what to use when? Again, it depends on your use case. I use that word because every customer use case unique and every project requires different kind of requirement. So for example, let's say you are just started working on streaming analytics where you want to build like a event-driven application. You can start with Kinesis data streams, and it has many integrations with many AWS services. But if you are very familiar with open source technology and you are familiar with Apache Kafka, then you can use Amazon MSK. And other consideration is about your application requirements. Your application requirement could be different based on your business use case. For example, Kinesis data streams with enhanced fan-out, you can achieve like 70 milliseconds latency. That is more than enough for many of the application, many of the use cases. but there could be a scenarios where you are looking for much lesser than that, right? But with Apache Kafka or in Amazon MSK, you can do the custom configuration with Apache Kafka, where you can achieve up to 20 milliseconds kind of a latency. That is possible with Amazon MSK. But if you wanted to have this kind of a custom configuration, that you can't do with Amazon MSK serverless. Amazon MSK serverless, the way it works is we look at your usage, how much streaming data it comes, and then automatically it will scale up and scale down so that you don't need to spend too much money and all. So, and again, the other advantage of Amazon MSK is like there is a lot of tooling for open source tooling. Like we have MSK Connect, there is a Apache Kafka Connect, right? So there are a lot of open source tools integration out there as compared to Kinesis data streams. So if you wanted to make it easy, simple, then start with Kinesis data stream. But if you are open source technology is your technology kind of a vision, you start using other open source technologies like Amazon MSK. Again, if you are looking for real configuration where you wanted to play around with Apache Kafka custom configuration, that is where you use Amazon MSK. And if you can't do that custom configuration with Amazon MSK serverless, we recommend starting your if you are planning to use Amazon MSK, maybe you start with Amazon MSK serverless, where you can do some POC dev environment and see how it is performing. Based on how it behaves, then you can either choose Amazon MSK serverless or Amazon MSK. Let's see, if you wanted to play around with Apache Kafka custom configuration, then choose Amazon MSK as compared to Amazon MSK serverless.
Yeah, that's like very detailed answer, but in simple term is like, if you want to be an open source engine, or if you are basically already having an Apache Kafka workload in your on-premises and you're trying to migrate them, MSK should be a straightforward option, right? So the one of the easiest way to migrate your streaming applications that already been running in Kafka, right?
Right. Yeah.
Correct. Yeah.
And then go ahead, Ram.
The migration aspect that you mentioned, Kalyan, I think that's a factor that we have seen with multiple customers, because many a time when they migrate, they might have that skill set in the team, right?
Exactly.
And so it will be a lot easier for the customers to make use of the skill set that they already have and migrate it. And that's a big factor that many a times play in choosing which one.
Same, because I've seen with my own personal experience, I've seen so many customers that migrated from on-prem Apache Kafka to MSK, because firstly, they already have the skill set and they already have the application, so that it's a seamless migration to them. And Kafka being a distributed system, it's not so easy to manage, right? You need a dedicated, high expert site reliability engineers, and you can completely reduce that cost by using this managed MSK service, basically. So we are managing your Kafka cluster so that you completely concentrate on deploying and bringing your streaming applications to the market as soon as possible. With that, let's take a look at other questions we have. So the next question would be is around choosing the right ETL service. We have a question like, the customer has a data analyst and they want to choose self-service ETL. So basically, how do we answer this question on people with different personas, right? So organizations have people called data analyst team who are trying to analyze the data, and they do have data scientists and dedicated data engineering teams. So which is the right ETL engine? So we have so many ways we can process the data in AWS Analytics portfolio. So how do we answer this question, Ram, right? Choosing a right engine.
Yeah, so to be frank, this is a question that I get a lot
I'm not
with the
surprised.
customers, because see, every enterprise will have all these personas. They will have teams who are very much into coding and who would like to code, and there are a lot of teams who are more of analyst roles, and they want to get insights, but at the same time they are not that comfortable in getting into the code level. And there will be people who are very well versed with the existing ETL tools, like the drag and drop functionalities and things like that, and they want to stick to that kind of a mechanism from a data engineering perspective. So we see these various personas a lot, right? And the good news is, if you look at Glue, AWS Glue as a service, right? The family of services, which includes AWS Glue and Glue DW,
Mm-hmm.
that together addresses all of these three personas. Because, for example, if I pick the AWS Glue, it has multiple options where, for a data engineer who wants to stick to that ETL kind of data transformation, right, they can very well go ahead and use drag and drop options. And the beauty of that is, as and when you do the drag and drop, you will get the actual code behind the scenes generated for you. And if you want to do some customizations on top of that, you always can edit that script, do whatever customizations that you want, and then move forward with it. Or even in the drag and drop, you have an option for custom code. So you just drop that node and just type in your code there. So that gives that flexibility for a data engineer role. And people who are really into the coding, either they can go ahead and edit the script that is out there, or you have an interactive sessions, Glue interactive sessions, which can help you with people who are really into coding, right? So that's the other persona. Now, the third persona that we were talking about is more of an analyst, or someone who is really prepping the data for machine learning use cases and stuff like that. So for such persona, the same Glue family has another option as Glue Data Brew, which is a no code option where it is simply point and click options, where you have 250 plus functions that are out there. Let it be uh, taking care of cleaning up your data, joining the data, pivoting, or machine learning functions like normalization, outlier detection, one hot encoding, all of these things, right? So these are all point and clicks. So Glue as a family, the good news to your question is, the Glue as a family of services can handle all these three different personas.
So when you say all these three personas, it could be the persona looking for a low-code ETL solution, and also completely managed functionalities like 250 plus transformations in Glue Data Brew, right? And also, if you want to bring in your own Spark expertise, if you have a data engineering team who can write a sophisticated Spark code, but you are looking for a managed infrastructure, you can bring in your own Spark code and execute on Glue, right? Is this how you say?
Exactly. Yeah.
Okay.
Yeah. So you have all of those that flexibility with the Glue services.
Got it. Thanks for answering that question, Ron. So the next question that we see here on the board is on auditing, right? In data governance, we are trying to use lake formation, but one of the important factor for us to consider is there a way we can audit the permission model? So Arti, do you want to answer this question?
Sure. Yes. So typically, lake formation is a service that we use recommend as a central governance model, wherein you have a database cataloged in Glue's data catalog, and underlying data sets are sitting on S3. So with the lake formation, we are saying that you can get away with all the S3's bucket policies, and you can also get away with the Glue's resource policies, right? So then we need a proper mechanism to ensure that correct principals or users, data lake users, are given the permissions, and we need to have a secure mechanism to audit that the right person access the right data sets. So AWS CloudTrail logs are available for lake formation for these purposes.
Mm-hmm.
So now these logs provide minute details about what database and tables were accessed, who accessed them, whether the IAM user, IAM principal, IAM roles, whether it is the SAML based user or whether it is the cross account, and at what time these were accessed to. And even when you are sharing Glue's database or a table across accounts, across AWS organization IDs, CloudTrail logs are still available for both the sharing and the consumer account, with all these levels of details of the access. And the customer or the users can build further tools that they can use as a dashboard to further build minute level of detailed dashboards that they want from these by processing these CloudTrail logs.
Thanks,
So
Aarti. So when
CloudTrail
you
log
say,
has all these details, Kalyan. Yeah, go ahead.
So when you say tools, and you brought in CloudTrail, I would like to talk about the new feature that was recently released, right? The CloudTrail Lake, right? So basically, this is a CloudTrail Lake where you can have all these logs into your data lake kind and have these logs exposed through Athena for you to generate queries on. So basically, you can pull out your audit reports out of this CloudTrail Lake and use them for your sake of audit purpose.
Yes, and using those Athena queries, like every organization, they have the access pattern of their data sets are unique, so they can, over a period of time, they can build reports using these Athena's SQL queries. They can build quick site dashboards and create customized dashboards as to say, for example, right, a particular data producer team owns a set of S3 buckets. They can customize their audit reports, quick site dashboards using these CloudTrail data lakes. They can customize and build a report that will have meaningful reports for who access exactly their data sets and at what time.
Got it. Yeah. So when customer is trying to use lake formation, they don't have to manage any bucket policies, right?
Yes, essentially. Yes. Yes.
So the next question here I see on is a broader question. How do you see customers and the industry moving forward in terms of focus areas in data analytics space? We have Taj on the call. Taj, I see you just joined. Do you want to answer this question? And also please introduce yourself.
Sure, Kalyan. Hey, everyone. First of all, apologies for the delay. My name is Taz. I lead the solutions architecture community for data analytics here at AWS. And Kalyan, thank you for that question. So part of my job here is to engage with the customers in their data analytics journey. And I mean, what I can see over the past few years, the maturity levels of customers building data analytics solutions has grown tremendously. And what we see nowadays is customers more focused around discovery and findability of their data. So this usually leads to conversations around data governance and metadata management. So these are the two areas where we see our customers focusing on in order to enable their line of business users, in order to have different data profiles and personas in the organizations to work more effectively around it. Now, keep in mind, even though the complexity of dealing with these two areas, data governance and metadata management, is pretty significant, at the same time, what customers are looking for is harder the problem, easier the tool to work with. And you'll see this reflect a lot in some of our AWS services. So the areas that we are focusing on as a pioneer in this space is essentially building mechanisms and providing solutions that address these two areas. But at the same time, the focus is the broad usage of these tools that provide solutions to these areas. So in short, this is the trend that we are seeing for most of our customers.
All right. And then when you said data governance here, because that's very important, right? Because we see huge adoption of data analytics in cloud, and you have the data put in your data lakes, and I see rapid adoption of transactional data lakes, right? So because the data being in data lake, being used by machine learning scientists, data analysts, and then we have more features coming in like Redshift data sharing, and having this centralized governance model is utmost important, right?
That's true. That's a trend, Kalyan. So because a lot of the customers needs to have that centralized data governance for multiple reasons. One is to easily get an idea what are the data assets that they have, because for many organizations it's very difficult, right? And the centralized data governance model is what enables them to get a holistic view of all the data assets that they have, and that makes the searchability of these assets as well as self-service capability a lot more closer and easy for them.
Sure. Thanks, Ram. The next question that I see is on MSK. Basically here, a customer is asking, what are the different authentication and authorization mechanisms that are provided within MSK? I'll go ahead and answer this question. So firstly, thanks for that question. And there are three ways you can implement authentication and authorization in a managed service for Apache Kafka. One is using mutual TLS. So you can use the TLS certificates managed by AWS Certificate Manager. And then one of the value add I see customers get when they migrate to MSK is the integration with other AWS services and also integration with IAM. So you can create an MSK cluster that can integrate with IAM. So all other applications that are running, whether it's like producer or consumer applications that are running on EC2, or you can AWS Lambda, can make use of this feature, right? So basically, you create an IAM policies for your Kafka authentication and authorization too. And then the third authentication feature is SASL Scram, wherein which use typical password authentication, where passwords can be managed, again, using AWS Secret Manager. So I've seen very good adoption of AWS IAM authentication because with IAM authentication, there is no overhead of managing access control lists. Otherwise, if you have to use mutual TLS authentication or SASL Scram, so you'll have to go for another authorization mechanization, implementing Kafka access control list. But with IAM policy can handle both authentication and authorization, and there is no overhead to manage Kafka ACLs. The next question I see is, okay, how fine-grained can permissions be defined in lake formation? Aarti, do you want to answer this question?
Yeah, sure. Just as we discussed before, like just to recap, lake formation is a service we want to actually pitch in as one of the centralized governance solutions. And so how fine-grained can we go defining the permissions when we use lake formation? So permissions can be granted at the data lake to different data lake users at various levels using lake formation. To start with, as a dataset owner, you can share the entire database to a data lake user. In this case, you will be sharing all the tables under that database. The next level, you drill down one level underneath and then say that you can share and choose a database name, and you can choose specific table names from that database to different users. Go further down one more layer, and then you can grant permissions by including or excluding certain columns of a table. So you'll select a database table name, and you'll see the options to choose or exclude certain columns from those tables. So you get to choose or share at the column level only. Next, there is a concept called data filters in lake formation. You create data filters on a table. And what this provides is this filters certain rows that you want to grant access to a data lake user. So in a data filter, there are three options. You will get to choose. So when you create a data filter on a table, you can choose. When you choose the table name, you will see three options there. So one is you can choose exclude columns, include columns, and then there will be a filter expression where you say a particular column value equals a certain value. Okay, so now when you choose to share all the columns without any filtering, and you provide a filter row filter expression, that means you have shared all the you have shared the entire table, but you have provided row level filtering. So now you have got row level filtering. Now when you use one of the exclude or include columns, you get to choose what columns you want to include or exclude, and then if you leave the row filter expression as a wildcard star, that means you have defined permission at the column level. The third option is, now when you use a combination of include exclude columns as well as provide a row filter expression, you have fine-grained permissions up to the cell level, because now you have included or excluded certain columns based on the column value also. So now you have narrowed down both column and row, so you are able to share at the cell level. So lake formation permissions, you can use very fine-grained access control up to a cell level of a table.
All right. Thanks. So, Aarti, now that you explained, something that I wanted to bring here is, with the rapid adoption of solutions like data mesh and also centralized data management, we have organizations with different teams and multi-account strategy, right? So when customers have the data or the teams working on multi-account strategy, does lake formation help with these features? So, but does data filtering at the cell level, row level, or filters, do they work with a multi-account strategy?
I would need to check that, but I would think yes, because when you create a data filter on a table, and when you come to the grant permissions option, you can choose the database name, you will choose the table name, and then you also get to choose the data filter which is applicable on that table. Say, for example, right, you can create multiple data filters on the same table, and the options for whom you want to share that particular database and table along with the data filter, you will have three options. You will have whether you can choose the IAM user or IAM role within the same account, or you can choose across account, and you can choose SAML based users and user groups. So you have three options. So to answer your question, you can choose a database, table, and data filter on a table to be shared across accounts also.
So Arthi, one question on that cross account data sharing, right? So so when it comes to lake formation, it can enable customers to share the data that is sitting on S3 across accounts to enable this common governance, centralized governance strategy, right? For example, they can share the glue data catalog and have that cross account data sharing enabled through lake formation rather than directly putting in the policies on the S3 and doing all of that share, right? So that can become a lot more seamless with lake formation, right?
Yes, that's a very purpose of a very ease of use, that highlight of lake formation, I would say, because it does away with all your writing complicated S3 policies, bucket policies, as well as glue catalogs, resource-based policies. So lake formation, you just have to share it cross account, just like sharing it with any other IAM entities within the same account. So it makes that level of easiness to share with cross accounts. Yes.
Thank you both, Ram and Aarti. We have 2 more minutes before we have to wrap up our session. As I highlighted the latest features like EMR, job scoped IAM roles. Does anyone of you has that feature that you want to highlight here? One of any AWS Analytics features? Okay, no problem. Then let's take one last.
Kalyan, I have one point I wanted to highlight. So this is about glue crawlers, introducing a feature of having a S3 based event notification. So for previously, whenever you want to run a glue crawler, right? So you usually go and run the crawler on your entire S3 prefix that you have defined earlier. But now, what about a new partition of data getting added, a new object that gets added to that huge table with large partitions and already existing large files in the S3? So you don't need to crawl the entire S3 location fully. So what this feature allows you is, as new objects get added to the S3 prefix or the S3 partition location for a table, it creates a S3 notification. SQS messages landed in the SQS service, and the next time glue crawler runs, all it does is an incremental crawl from those locations of where to grab just the new objects and modify the glue catalogs table entry. So that's one feature I wanted to bring to audience notice.
Thanks, Ari. So basically, we're trying to reduce the total time the crawler takes and also amount of data it scans, right? Yes. So basically, it's an interesting feature which provides both cost optimization and also performance of your crawler.
Yes.
Okay, I see we are on top of the hour. thank you everyone for joining today. I hope this session was helpful and we're able to answer all your questions. Once again, thank you.
Thank you.
Thanks,
Thank you
everyone.
all.